Okay, so we are now doing number 18 on this lesson 7-4 homework assignment. So let's just jump right in and start off by finding x or y intercepts. So x-intercepts, we'll let 2x equal 0 and solve. So it looks like we're going to be passing through the origin. And we know then that the y-intercept also has to be 0. If I let x go in for all three zeros, the result will be 0. All right, so I've identified the origin as an intercept. Now let's see if we have any asymptotes. So for vertical asymptotes, numbers that make the denominator 0, x is -2, x is +5. Sketch those out. Here's x is -2 and +5. All right, and then for horizontal asymptotes, the denominator is 2 degree, is 2, and the numerator degree is 1. So since the denominator degree is larger, we have a horizontal asymptote at y equals 0. And just looking ahead, we know without solving, we know since we have a y-intercept, xy-intercept here, the origin, is on top of that horizontal asymptote, so we know it's going to be crossed. We don't have to prove it, but if you did want to prove it, I'll just go ahead and do that. Just let 0 equal the function and solve for x. So if you multiply by the denominator on both sides, you get 0 equals 2x, and then x is 0. So anytime you do this little test and you get a solution for x that is a real number, that indicates, yes, you are going to be crossing, and at 0 is where we'll be crossing. So it's always good to confirm what you've already done in another way. It just gives you some assurance that you're doing the right thing. Okay, and then for oblique asymptotes, we do not have one because the numerator degree is not one more than the denominator. All right, so we can go ahead. We know we're only crossing this horizontal asymptote in one place, so either this left part, this extreme left, to the left of this vertical asymptote, x equals -2, it either has to reside above, which we would call the positive section, or the negative section. It can't be both because it can't cross over y equals 0. So do a table of values, and we'll do an input of -3. So if I input -3, we'll just do a little math here, see what comes out. All right, so that's -6 over -1 times -8. So it's -6 over 8, which reduces to -3/4. Okay, so -3, -3/4, about right there. And so now we know pretty much all we need to know to get a rough sketch. We're going to go through this point, and we're going to trace this horizontal asymptote going as x approaches -infinity, and then we'll trace this vertical as y approaches -infinity. All right, and now let's work on the middle. Just erase my work. Okay, so we're going to be crossing through the origin, but do we come from this direction or from this direction? We don't really know for sure. So just doing an input will tell us. What if we input -1 in place of x? Okay, so negative 2 over, this is positive 1, and this is negative 6. Negative 2 over negative 6 makes positive 1/3. Right, so that gives us all we need to know there. Negative 1, positive 1/3 tells me that I am going to be coming through that point, coming through, passing all the way through the origin, and then I will approach this other vertical asymptote as y approaches negative infinity. And then here I'll be coming up as y approaches positive infinity. So we went through our point, we went through our intercept, and it looks something like that. Not easy to sketch these with this board, but I think you get the idea. Yours probably looks a lot nicer and neater. And last section, what happens to the right? So let's input the first x that we come to the right, which would be x equals 6. All right, so if I input 6 in for x, 2 times 6 over 6 plus 2 times 6 minus 5, 12 over 8, which reduces to 3 over 2. So input 6, output 1.5. And then the same logic, we know we're not crossing again over the horizontal asymptote, and we will always follow, never cross vertical asymptotes. So that is your answer then for number 18 on this assignment. All right, let's jump on over to number 20, and let's see if we have x or y intercepts. So x plus 3 quantities squared equals 0 to find the x-intercept. Square root of both sides. Subtract 3. I will have an x-intercept at negative 3. All right, so for the y-intercept, I'm going to put 0 in for both of the x's. And when I do, I get 9 over negative 5, negative 1 and 4/5. Now, I worked this problem out previously, and I realized this one's kind of unusual because the numbers, the y values that we're going to be plotting are quite big. I already know that ahead of time, so I'll go ahead and give you a heads up. We can make these into 5s or even 10s if you like. 10s should be able to handle everything pretty easily. So I'm just going to go ahead and say that my y-axis is in terms of 10 each. So that makes this y-intercept real close, just slightly below the origin. All right, and we don't have to change the x, we'll just change the y. Okay, so nothing factors. We do have a vertical asymptote at x equals 5. And we don't have a horizontal asymptote because the degree of the top is bigger than the bottom, but we are going to have an oblique. So I'm going to come down here and set this up, and I'm going to go ahead and expand x plus 3 quantity squared so we can divide into it and find out where our oblique asymptote is. So x into x squared goes x times. X squared minus 5x, subtract, and I get 11x to bring down the next number, which is not really necessary because all we have to do is get the mx plus b part. And you'll see right away our oblique asymptote is y equals x plus 11. So that's about right there. And And since counting out the slope here is a little bit tricky since my x and y axis are in two different units, I'm just going to do some inputs. Like if I input 4 in for x, I get y is 15. So this is 10 and this is 15. And let's just get one going the other way. If I input, let's just say -6, I'm going to get an output of 5, which is about halfway. So I'm going to try to line those 3 points up, and that's going to be my oblique sketch. All right, looks like we have everything we need. Let's see if our oblique asymptote will be crossed. So I'm going to take x plus 11 and let that equal the function. So when you multiply by x minus 5 on both sides and do FOIL, that's x squared plus 6x minus 55. And on the right side, of course, these would cancel. The x squares would cancel. The 6x's would cancel. And so we've got proof or assurance that since -55 does not equal none, of course, we can't solve this and get a real number for x, then our oblique asymptote will not be crossed over by our graph. Okay, so let's get into what happens with this graph. So we can do some inputs and outputs. So on the left side of this vertical line, knowing that I'm never going to cross over this oblique asymptote, I can pretty much just use these 2 points, the y-intercept and this x-intercept, and I know that my one section is going to look like this. I just need to see what it looks like over to the right of this vertical asymptote. So this is line x equals 5, so let's input 6 into this. 6 plus 3 squared over 1. So 9 squared is 81. So when I input 6, I get an output of 81. 1, 2, 3, 4, 5, 6. 1, 2, 8, and then a little more. And so once again, erase that. We could keep on going. Let's just go ahead and do one more. What if we input 7? So that would be 100 over 2, which is 50. 10 squared over 2, so 7. All right, and I think that's enough to give us a little clarity. We know that we're going to be passing through those, going up forever, and then we'll come through this bottom one and we'll just continue to approach this oblique asymptote forever, going toward x is going toward positive infinity. Okay, there is your answer for number 20. And now let's look at the last one, number 22. This will be the last one for this assignment. All right, so back to the old routine, x-intercepts. Let's see, 4x cubed equals 0. Divide by 4, cube root of both sides. x equals 0, so again, that means we're going to be passing through the origin. If we let x become 0, we get y-intercept of 0 as well. So those are our intercepts. All right, vertical asymptote, we need to get this factored first. So let's go ahead and factor this out, the denominator. If you like, you could use the box method here. So the factors of -1 would be +1, -1. So we're going to have two vertical asymptotes. One will be at +1/2, and the other one will be at -1. All right, so sketch out +1/2. And -1. And we've already said we're going to be crossing through the origin. Let's see if we have a horizontal asymptote. Looks like we don't. Top degree is bigger than the bottom. Let's see if we have an oblique asymptote. And it looks like we do. The top degree is 1 more than the bottom. So we're going to divide the denominator, 2x squared plus x minus 1, into 4x cubed. So 2x squared goes into 4x cubed 2x times, and then multiply 4x cubed plus 2x squared minus 2x. Subtract. So the x cubes cancel. This is just 0 minus 2x squared. That's -2x squared. And you could go ahead and bring down the plus 2x if you like, but all we need is the mx plus b part. So 2x squared into -2x squared is -1. So we have an oblique asymptote of y equals 2x minus 1. Let's see if that oblique asymptote will be crossed. So let's let 2x minus 1 equal the function x squared plus x minus 1. Okay, so we're going to multiply this denominator on both sides. So it's been a while since we've done this, but it's just the distributive property. So distribute 2x to both, all three terms. So that would be 4x cubed plus 2x squared minus 2x. And now distribute the -1. And then combine like terms, and we get 4x cubed. The x squares cancel. -2 minus 1 is -3x. And then plus 1. Okay, so that's the result of multiplying this denominator on both sides, or on the left side. And on the right side, it's just going to cancel and leave us with 4x cubed. Well, the x cubes cancel. I'm left with 3x plus 1 equals 0. -3x equals -1, so x is 1/3. So I will be crossing over my oblique asymptote, and where I'm crossing is where x is 1/3. So right in between the origin, I'll go with smaller so you can see it, right in between the origin and this y or x equals 1/2, we should be crossing over our oblique asymptote. And we'll see if that's actually true in just a minute. Okay, so let's sketch out the oblique. So here's -1, and then a slope of +2 up to right 1. Right, and Just draw a dotted line to represent that oblique asymptote. Not real straight, but I guess it'll do. And now let's see what our graph looks like. We'll start doing some inputs. I'm going to erase my work down here and put up a little table. We're almost there. Okay, so to the left of this vertical asymptote, we're going to choose -2. So if I put -2 into this function, either one of these, doesn't matter which. I'm just showing, not that you have to write all this down, but for those who may be a little bit, you're not following what I'm doing, I'm just going to provide a little bit extra detail. So -2 to the third is -8 times 4, that's -32. And down on the bottom, this is 4 times 2 is 8, minus 2 minus 1. So -32 divided by 5. And I'll just go ahead and get the decimal of that. -6.4. All right, so when I input -2, I get -6.4. There's -6. 1, 2, 3, 4, 5, 6, and then a little bit more than that. Well, I know my only place of crossing over that oblique asymptote is up here at x equals 1/3. So I'm pretty confident that the rest of this graph falls in this little pie-shaped area right here. And now we've got a piece that's really 3 different sections. I got 2 vertical asymptotes, so I'm going to have 3 different parts to this graph. In between these 2 vertical asymptotes, I know I'm crossing through the origin, we determined that, and I know I'm going to be crossing over the oblique asymptote. So just to give a little bit of clarity, I'm going to go ahead and input -1/2. All right, so let's put -1/2 into our function. I'm going to erase my work here. And we'll see what we get. So it looks like I got +1/2 when I plug that in. So input -1/2, output +1/2. So now I'm going to put all that together. That tells me that when I do come through the origin, I'm coming from this direction. And when I go through the origin, then I'll have to follow, this is getting a little tight, but I'll be following this vertical asymptote going down forever. So it's a real skinny, if you remember what x to the third looks like, the parent function, this is flipped, but it's the flipped version of that. Okay, so we just have one more piece. And so let's see about to the right of this vertical asymptote. So let's do input 1. So that should be pretty easy. 4 over 2 plus 1 is 3, minus 1 is 2. So input 1 gives me an output of 2. All right, so this other piece has to reside within this pie-shaped region because we know we're not going to cross the oblique again. So that should be the third piece. All right, I think we got them. And that's all that you were expected to do for this assignment. And hope this helps. But if you need help, you're always welcome to email me or come see me before class. And I will see you next time.